everyone. So today we're going to learn about class diagram. So what is class diagram? This is example of how a class diagram looks like. So you can see here the main thing here is element here is the car. So we have branches over this car, which is the car model, engine, body, brake, and other components. So in software engineering, a class diagram, the Unified Modeling Language (UML), is a type of static structure diagram that describes the structure of a system by showing the system's classes, their attributes, operation or methods, and the relationship among objects. So this is an example of how UML diagram looks like, and we are focusing on the class diagram specifically. So the purpose of the class diagram is to show static structure of classifier in a system. 2. Diagram provides basic notation for other structure diagrams prescribed by UML, helpful for developers and other team members. Business analysts can use the diagram to model system for a business perspective. A UML class diagram is made up of a set of classes and a set of relationships between the classes. So what is a class? A description of a group of objects, all with similar roles in the system, which consist of structural features and behavioral features. So a class consists of two things, which is structural features and behavioral features. So what is structural features? Structural features define what objects or class know. So represent the state of an object of the class, and description of structural or static features of a class. Let's say we take a car, and what is the structural features of a car? A color of the car or the shape of the car. And what is the behavioral features? Define what object of the class can do. Define the way in which objects may interact. Operation or description of behavioral or dynamic features of a class. So what a car can do? It can travel on the road. You can drive the car. It can go faster, it can go slower. So let's look at the class notation. A class notation consists of three parts. Class name. The name of the class appears in the first partition. The class attributes. Attributes are shown in the second partition. The attributes type is shown after the colon. Attributes map onto members variable. Data members in quote. Class operations or methods. Operations are shown in the third partition. They are services the classes provides. The return type of a method is shown after the colon at the end of the method signature. The return type of the method parameters is shown after the colon following the parameter name. Operations map onto class method in code. So this is example of a class diagram. So you can see here, my class attribute 1 is integer, attribute 2 is float, attribute 3 is circle, and then the boolean, string, float. So we have different things going here. So this description is explain what is this class diagram is about. So a class relationship. A class may be involved in one or more relationship with other classes. A relationship can be one of the following types. Refer to the figure on the right for the graphic representation of the relationship. So this is relationship type. So at the right side we show the graphical representation of this relationship type. So the first relationship type is inheritance or generalization. Association, a structural link between two pure classes. There is an association between class 1 and class 2. A solid line connecting two classes. So this is the solid line connecting the class 1 and the class 2. The third relationship is aggregation, a special type of association. It represents a part of relationship. Class 2 is a part of class 1. So you can see this arrow here denoted by star of class 2 can be associated with class 1. Objects of class 1 and class 2 have separate lifetimes. A solid line with an unfilled diamonds of the association and connected to the class of composite. So next thing is composition, a special type of aggregation where parts are destroyed when the whole is destroyed. So next thing is dependency. Exists between two classes in the change of the definition of one may cause changes to other. So if class 1 destroyed, the class 2 will be destroyed. So the relationship names of the relationship are written in the middle of the association line. Good relation name makes sense when you read them out loud. Every spreadsheet contains some number of cells and expression evaluates to a value. They often have a small arrowhead to show the direction in which direction to the read relationship. For example, expressions evaluate values but values do not evaluate to expressions. Navigability. The arrow indicate whether given one instance participating in a relationship, it is possible to determine the instances of other classes that are related to. The diagram above suggests that a given, so this is the diagram. So it suggests that we can locate all the cells that is contained, but that we cannot determine from a cell in what a spreadsheet it is contained. Given a cell, we can update the related expression and value, but given a value or expression, we cannot find the cell of which contains the attributes. So visibility of class attributes and operation. In object-oriented design, there is a notation of visibility for attributes and operation. So these are the symbols that will be used in the class diagram. So the class visibility example. So let's look at the class visibility example. So you can see there's public, private, protected, and package things here. Members of the same class. It's all goes for public, private, protected, and package. Members of derived class are in public and protected and package, but it's not in the private. Members of any other classes, so it is in public but not protected, and it is in the same package. So multiplicity. How many objects of each class take part in the relationship, and multiplicity can be expressed as exactly 1, 0 or 1, many or 1 or more. Exact number 3, 4 or 6, or a complex relationship 0, 1, 3, 4, 6 would mean any number of objects other than 2 or 5. So this is example of multiplicity example. Requirement: a student can take many courses and many students can be enrolled in one course. The student takes course. So many students can take software engineering. For example, Mary and Jane can take software engineering, and a course can be enrolled by many students. For example, database management course and software engineering course is both taken by Mary. Aggregation example. So this is a computer. What a computer is consists of: monitor, motherboard, CPU, memory. So what is a CPU consist of? Cache, ALU, program counter. Inheritance example. So what is a cell will produce? Muscle cell, blood cell, and nerve cell. So what a muscle cell will produce? Smooth muscle cell. A blood cell will produce red blood cell, white blood cell. So class diagram, a diagram tool example. So this is a class diagram with complex relationship between each of the elements. So dealing with complex system, multiple or single class diagram. If you're modeling a large system or a large business area, there will be numerous entities you must consider. Should we use a multiple or a single class diagram for the modeling the program? The answer is, instead of modeling every entity and its relationship on a single class diagram, it's better to use multiple class diagrams. Dividing a system into multiple class diagrams makes the system easier to understand, especially if each diagram is a graphical representation of a specific part of the system. So let's look at the perspective of class diagram in software development life cycle. Conceptual perspective. So a diagram can be used to interpret things that happening in the real life. Specification perspective. A diagram are interpreted and to describe a software abstraction and components of the software means we can use this class diagram to describe how our software will be look like. Implementation perspective. So software engineering usually use this class diagram to describe the softwares using real life language, so that all of the software engineers can understand what they are going to do, what kind of system they're going to develop with the class diagram.
I'm going to explain about class diagram symbols and notation. Firstly, we have classes. Classes represent abstraction of entities with common characteristics. We illustrate classes with rectangles, divide into compartments, place the name of the class in the first partition, and list the attributes in the second partition. And the last partition is for operation. Next, we have active class. We illustrate active classes with a ticker border with like this. Active class is to initiate and control the flow of activity. Next, we have visibility. We use visibility markers to signify who can access the information contained within a class. In private visibility, we use a minus sign for private. For public, we use a plus sign. For protected, we use a hashtag sign. And for package, we use this sign. Next is we go to association. Association represents static relationship between classes. Place association names above, on, or below the association line. Like this. We use a field arrow to indicate the direction of the relationship. Place rows near the end of the association. Rows represent the way the two classes see each other. Next, we have cardinality. We place cardinality notation near the ends of the association. This symbol indicates the number of instances of one class linked to one instance for other class. For example, one company will have one or more employees, but each employee works for just one company. This is the symbol. This is the example of indicator and the meaning of it. Okay, next we have constraints. We place constraints inside curly braces like this between the classes. Okay, next one we have composition and aggregation. Composition is a special type of aggregation that denotes a strong ownership between class A, the wall, and the class B, the part. Illustrate the composition with a filled diamond, display diamond, and use a hollow diamond to represent a simple aggregation relationship in which the wall class plays a more important role than the part class. But the classes are not dependent on each other. The diamond and in both composition and aggregation relationship point to the wall class. So this is example of the composition. We use the filled diamond symbol like here, and the aggregation we use and the other one we use a white symbol, white empty diamond symbol. Okay, next one is a generalization or inheritance, or is a relationship. It refers to a relationship between two classes where one class is specialized version of another. For example, Honda is a type of car, so the class Honda will have a generalization relationship with the class car. This is the example of to illustrate the inheritance of classes.
Hi everyone. I'm Shasita. I'm from Team Codex, and today I'm going to explain the case study that we are going to use in order to explain class diagram. So let's get it started. In order to explain class diagram, we have chosen the case study of students' FYP management system. FYP final year project is one of the core elements for a university student during their studies because it is one of the criteria to be fulfilled in order to graduate after 4 years. In order to manage the data of final year students and their respective final year projects, School of Computing (UTM) has decided to develop a system called Student FYP Management System. This system will consist of all the details of final year students at School of Computing (UTM) regarding their final year project and also the lecturer who was assigned to oversee their final year project performance. Therefore, you and your team are given the responsibility to develop the student's FYP management system. Further details regarding the system are as per below. So this system, the student's FYP management system, will consist of three main classes, namely the student class, the lecturer class, and also the project class. The class student is the primary key which will contain the final year students' basic information as attributes, such as their name, their course, lecturer, and also their FYP project. There are several functions in this class which are mainly to store the data and also to access them when needed. Besides, the class lecturer consists of the lecturer information. So in this class, the information regarding the lecturer who was assigned to the final year student in order to manage, oversee, and also to advise on their FYP performance. Next is there are functions in the class lecturer to store the lecturer data and also the function to access the lecturer information. In the project class, which is the third class, it will consist of project name and lecturer name as the attributes. It consists of functions to input the information of lecturer and also the project, as well as to access the information when needed. Alright, based on the criteria given, draw a class diagram to represent the student's FYP management system, which will consist of all the necessary classes, attributes, and operations as mentioned above. Alright, this is the case study that we're going to use in order to describe class diagram. Let's get it started.
Okay, so we go to the next step, which is designing the class diagram. So we will refer back to the case study, which is the student FYP management system, which is student final year project management system. Okay, so what are classes that available for this case study, and what are the attributes that we need inside the classes? Okay, so first class is student class. Okay, so what are the attributes that inside this student class? Okay, so first is student name, and then the course, lecturer, project, and the method of the functions are student, which is we use it as the constructor, and then get data and get name, get course, set project name, set lecturer name, and get project name, and also the get lecturer name. Okay, so this is this class diagram that we need to draw when we start to analyze all the problems, okay, for build a system. Okay, so what things that consist that in this class is 3 rows, okay, which is the first row must, okay, we insert the class name. Okay, so since this is the student class, so I name it as the student. And then the second row is variables or the attributes. Okay, so this is all the variables, and we set it as private. Okay, as private because we don't want these variables can be accessed outside of the class. Okay, and the third row is method or functions. Okay, so this is the constructor, which is we will initialize all the variables, and then we get data. We will use it as to receive the data or to return the data to the main. Okay, and then get name, same. We divide it into the small function because it will be easier to detect or to recognize if there is some errors when we execute the program. Okay, so and furthermore, which is the set project name, set lecturer name, and more. Okay, and the next is the lecturer class. Okay, what is the attributes, which is name of the lecturer, and the method or functions is lecturer, which is the constructor, set lecturer, which is set the lecturer name to the variable, and then get lecturer, which is we just receive the data from the set. Okay, so this is the class diagram for the lecturer. So this is the variable, and then this is the method or functions. Okay, and the last class is the project class, which is consists all the details about the project. Okay, so the attributes are lecturer name, project name, and the method or the functions are project, which is the constructor, and then set project name, set lecturer name, get project name, get lecturer name. Okay, so this is the class diagram for the project. Okay, so this is the function. So all of this class diagram, we must combine it using a relationship, so it will become easier for the compiler to know the flow of the system. Okay, so we call it we also call this diagram as UML class diagram. So this is the student diagram, class diagram, and then this is the lecturer class diagram and the project class diagram. So I relate these 3 tables using the aggregation and composition, which is have some functions and features that able to make this system become more efficient. So yeah, this is the class diagram for the case study. Thank you.